Good morning, madam.
Good morning, sir.
Ma'am, good morning. Dr. Bandela.
Yeah, am I audible to you, sir?
Yeah, you are audible. So,
Okay.
before the introduction of yours by the participant, on behalf of Dr. Baba Sahib Ambedkar Marathwada University and on the behalf of UGC-MMTTC, I warmly welcome as a coordinator of this course, Dr. Suja ma'am for this particular session. I hope that participants will be enjoy. I know that your capacity and you are the frequently coming to our programs all the time. I'm very thankful to you that you are appreciated our invitation and you are given your valuable time for our all the teachers. So on this board, total 75 teachers are there from different disciplines, as you know well. And you can continue now. So before this, once again, on behalf of Vice Chancellor and even the directors and all the non-teaching staff and from my teachers, I warmly welcome to this program. Thank you, ma'am. Please, who is roll number? Now is going to introduce the ma'am.
Thank you, sir.
Thank you. Welcome.
Good morning, sir. I'm roll number 17. I'm asked to introduce our today's guest. Shall I start?
Yes, sir.
Yes.
Good morning, all respected teachers. I am Dr. Mayur Khedkar from Department of Chemistry, Hislop College, Nagpur, roll number 17. On the behalf of UGC, Malviya Mission Teachers Training Center, Dr. Baba Sahib Ambedkar, Marathwada University, Chhatrapati Sambhajinagar, it's an honor for me to introduce our today's guest speaker. Today's guest speaker is Dr. R.S. Suja Rose. She is head Department of Environment, Remote Sensing and Cartography, ERAC, School of Earth and Atmospheric Sciences, Madurai University. Madam's research area is temporal analysis of water resources using remote sensing and GIS. Madam has teaching experience of 15 years and research experience of last 20 years. Madam has published 6 book and book chapters. There are 12 research papers to her credit, and she has presented 4 papers and 6 papers in international and national journals, respectively, in conference proceedings. Madam has presented 44 research papers in the conferences, and she has attended 4 workshops. Madam has undertaken 15 training programs. Under her guidance, 5 PhD students are awarded the PhD degree, and currently 3 are working under her guidance. 35 PG students have undertaken their doctoral, master's program. Madam was a coordinator of more than 30 certificate courses, both on basic remote sensing, GIS, GNSS, and advances in geoinformatics, conducted by the Institute of Remote Sensing, Dehradun, through the EDU SAT distance learning program. Madam offers consultancy services to two government projects and 1 company in the field of geospatial technology. Madam is also a member of various reputed bodies, like life member of Indian Society of Genomics, life member of Indian Society of Remote Sensing, life member of Indian Society of Geography, and fellow member of Scientific Society of Advanced Research and Social Changes. This is a brief introduction about the madam. I welcome madam once again for our today's session. Thank you.
Thank you, Professor, for introducing myself. I take this opportunity to thank, first of all, Professor Dr. Mule for introducing me first to this university. And I also thank the director, UGC-MMTTC of Ambedkar University, Aurangabad, and other members and other faculty who have invited me to share my experience here. So maybe Today, as a faculty of remote sensing, I'm very happy to stand before you and share some experiences which I have gained throughout my career. And as I am aware that all faculty members and the faculty friends are from various fields, or here are attending this program, maybe I will try my level best to convince you by making myself very clear. So if you're having any doubts, you can just raise and ask me. So that I hope that the session will give a fruitful time for you. Shall I? Maybe I will start sharing my screen. Am I audible to everyone?
Yes, ma'am.
Yes, madam. Yes.
Okay. Is my screen visible to all of you?
Yes, madam.
Okay.
Yes, madam. Yes.
I can proceed, right? Okay. So today I'm going to discuss with you about a topic like climatic change and sustainable development, a geospatial perspective. So from geospatial point of view, how climatic change and sustainable development has to be addressed. So that's what I want to share with you, right? So as sir introduced, I belong to the Department of Remote Sensing and Cartography of Madurai Kamaraj University in Tamil Nadu. And we are offering a PG program in remote sensing and cartography, remote sensing and geoinformation technology for the past 26, 27 years with a student strength of nearly 12 per year. And it is going on as such apart from whatever Sarah has told. So anyway, maybe I can very proudly say that most of our students are placed in almost all the places because starting from 1996 onwards, we are offering the course. So anyway, with that experience also, maybe I can share a little bit of information to you. Okay. So in today's session, maybe I have divided my lecture in two parts. That is session one, maybe up to before break, we will discuss about the basic concepts and theories which is related to this technology, like the geoinformation technology. Then after the break, maybe we can discuss something about the application and case studies, how we can address the climatic change and sustainable development issues, right? Okay, so climate change, actually, it refers to like climate change and sustainable development. Here, when we think about this, there certain points come to our mind, like see climate change to sustainable development. It is causing a very big threat for sustainable development. So mostly when we think about climate change or sustainable development, you see both are connected together. And here the climate change actually, it causes a lot of threats to sustainable development. When you think about sustainable development, sometimes what happens is these climatic change issues may come in between, like a noise, I can say. So when there is a change, then we have to address the climate change and then come back to the sustainable development. So that's why it creates a lot of threats. For example, environmental degradation. Maybe you see sometimes when we think about environment and we think that, okay, environment is going to get degraded. So just we will take some issues or some plans to safeguard the environment. But in between, climate change may come and you see it will hinder our development process. So that's why it causes a threat. Likewise, you see sometimes whenever there is a climate change, it actually brings a lot of problems or hazards to us. So what happens is, in between you will have economic losses, some social inequality problem, and other things, right? So it causes threat to the this sustainable development. Again, likewise, the second point comes to our mind is whenever we do a sustainable development, definitely it can address the climatic change adverse effects also. So definitely, we can say that sustainable development is a solution for climate change impacts. So anyway, so climate change mitigation and adaptation can be done, can become a solution for climate change impacts. Likewise, it causes sustainable agriculture. It causes sustainable agriculture and food security. When we think about that, there also we have to take resilient agricultural properties. Likewise, water resource management. There also we have to address both water scarcity and flood management. So whenever there is a climate change issue, what happens is it maybe we will be expecting some rains, and that time we may not receive the rains. And sometimes we will be expecting like summer, at that time you will have a very big rain. And what happens is all plants may get into problem. So water resource management is also very, very important. Wherever water scarcity is there, as far as India is concerned, one place will be having a very big drought, and in the meantime, in the same time, in the other place you will be having a severe flooding conditions. So this is the reason. So as a country, we have to manage both flood as well as water scarce. So the importance of spatial data or spatial area becomes very, very important. Again, urbanization and sustainable cities are also very important. Like when we go for urbanization, we will come to this point, because this is the main anthropogenic effect which actually accelerates the climate change problems. So when this happens, you see, we should be very cautious by giving a sustainable urbanization. Likewise, we should go for 3 R's, like reduce, reuse, and recycle. So this is the sustainable cities can be maintained. Likewise, public health and climate change also becomes a very big problem, because we need to give a very equal you see, the health impacts also. Am I audible to everyone? Is there any problem?
You're audible, madam.
Okay. I got some disturbance, that's why I was, okay. So the climatic change affects the health impacts of the people, and in the meantime, we have to give equal health, equity in health also. So that's why how the spatial or the GIS or whatever the spatial perspection should be very good in addressing all those things. Like this, global climatic governance also should be there. So climate change, it actually depends not only local people or the whole change depends upon the whole nation of the globe, right? So all world countries has to take proper efforts to reduce the climate change impacts, or to reduce the source from which the climate change impacts happens. So for all these, the very important thing is we need data, and all the problems are very area specific. So maybe we can say, or whatever we have discussed till it is totally area specific, and that's why we need each and every data for each and every part of the globe. That's very important. So that's why we think about it. So anyway, the sustainable development goals have been framed by UN, and we are working towards that for the past few years, and we are trying to go to a very good world. So for that, actually, when they have framed the 17 goals, UN has taken, and we can see here out of 17 goals, 5 goals, they are directly dependent, they are directly related to climate, right? One goal is totally for climate change. That's very important. So that's why you see the affordable clean energy, sustainable cities and communities, then responsible consumption and production. Likewise, the climate action, that is totally for climate change. Then the life below water and life below land. So all these goals, they are concentrated towards the climate change. And so that's why you see out of 17, if 6 are towards the climate change, that much importance we are giving to climate change and its effects. So that's why each and every one of us, each and every one citizen of the globe, maybe I can say, so everybody has the responsibility to answer these climate change issues. So that's why very much we are concerned. And nowadays, if you see, most of the projects or most of the calls come related related to climate change. So that's how it's getting its importance. So whatever field we belong or whatever area we belong, we have to contribute something for the climate change and others. So it's not completely dependent upon government or any other thing, but it's depend upon each and every one of us, each and every citizens, each and every students, and each and every baby who born in this earth, right? Okay, so how actually BBC News says that, you see, recently it has told that it's a very long-term shift in the Earth's average temperatures and weather conditions. So that's why we can't predict anything very, maybe you can say, we can't predict everything 100%. So there will be some ifs and buts because of this climate change. So this is, as a result, you see, we can say like the world's average temperature was like 1.2 degree rise than the last century. So in the previous century before, you see, there is a rise of 1 degree Celsius means it causes a lot of effects in the agriculture and other things. So likewise, even you see, it is confirmed that, you see, the global warming has exceeded 1.5 degrees Celsius across 1 year, and it has been recorded that 2023 is the warmest year in this year. So that is how it has happened. So likewise, this temperature increase is naturally occurring. So usually when we see the evolution of Earth from the beginning, maybe that evolution of Earth history itself will say certain years of warm and certain years of cool, right? So anyway, it happens. So that happens naturally. But here the problem is then.
Ma'am, sorry to interrupt. Milind Wag, should I remove you from the meeting? Shall I proceed, sir? Yes, proceed, madam. Proceed.
Yeah. Okay.
Hello. Madam, one request to you. Please share your PPT in large scale, madam.
I couldn't get you, sir.
Please share your PPT in large scale. They are seeing in small scale.
Full screen. He is telling that full screen, unko words dikh nahi rahe.
For me, it is full screen only, sir. I am sharing it in.
It is a problem of Zoom, sir. If it is a problem, madam is right. Roll number 57. It is a problem of Zoom. You can continue, ma'am.
Okay,
Yeah.
madam.
I think in the maybe in the top there is a small small thing, but everything is visible only. I don't know. Maybe so you can check your system. Okay.
Okay, madam.
Okay, thank you. So okay, so maybe the climate change.
Okay, ma'am.
Shall I continue, sir?
Yes, ma'am. Yes.
Okay, so even though the climate change is natural, but human-induced parameters are very much important because it actually accelerates the climate change process, and that's why we should be very cautious, right? So we know weather and climate, whatever. So here the important point is weather and climate data is there. It's needed. So weather in the sense, you see, we need daily or hourly data. That is one point. And in the other point, we should have a long time data also. That is very important. So maybe hourly or even minute by minute data, it's also needed for certain parameters in order to predict weather or something. And we need long-term data also. Maybe for example, if you want to do something for climate change, usually we take 30 years data, right? So then we need a very long time data also. So data requirement is very important as far as weather and climate is needed. So likewise, you see, research in this area is very much needed from various fields. So usually environmental science, it actually takes a multidisciplinary nature. So that's what you are all here for a refresher course. Environment actually requires people or the professionals from various fields. So similarly, this climatic change also, it requires people from so many areas. So that's why we are very much concerned, right? Okay. So we know that weather conditions, if there is a thunderstorm, if there is a tornado, if there is a downburst, or if there is a cyclone, all these are the weather conditions. But these also cause a lot of loss to the life and property. So that's why we should address this type of thing. So similarly, climate change events are also there. So weather events also requires a lot of data, and climate change events also requires a lot of data. Like we see the map which you see. see, actually it shows the data from 1951 to 1980, or it can extend up to 2020 also. So we need data like 30 years or 50 years. So when we monitor in the 30 years or 50 years data only, then we can see how it has raised. So like global temperature anomaly, on an average, it is raising like anything else, right? So in order to perform such type of predict such type of climatic events, we need a lot of data which has to be in our archives, right? So likewise, we have found that, like, see, there is a change in temperature as well as there is a change in rainfall also. So whenever there is a change in temperature and rainfall, we should be very cautious. So here in this globe, actually in this picture, if you see, there are red areas where you can say that the change is very much pronounced, right? And likewise, such type of data or such type of interpretations can be made when we have like 30 or 50 years data, right? Okay, so here the Indian Network for Climate Change Assessment, it has prepared a report and it has said that this India, you see, there is a lot of change as far as our country is concerned. Here, you see, there are some average temperature rise of 2 degrees there in certain cases, and there is an increased annual precipitation. But you see, here the problem is there is increased annual precipitation, but the problem is low frequency of rainy days and increased intensity. So this is a problem which causes floods, right? So when the number of rainy days is reduced, and in a single day, if you have a very heavy downpour, then what happens? There will be a lot of flood and other disturbances. So likewise, the cyclonic disturbance is also like that. There is a lower frequency as well as increased intensity. So all these happens. There is a increased sea level rise, and so that, see, the freshwater supply is also getting affected. So how there are so many. What happens here is the drought areas will become more and more droughter, and the wet areas will become more and more wetter. So definitely there will be a lot of challenges in facing such type of climatic change issues. So similarly, you see, Times of India has also given a news telling that there is a rise in temperature, right? And that's why the tropical cyclones has affected as well as the sea level rise. So what happens here is the planning becomes again problematic for us. So here actually, this is a climatic region which is given by Köppen-Geiger classification. Even we can see when we predict, like when we see the region, you see there is a change in the region. You can see the blue color, it's being increasing. So here, the Deccan Plateau area as well as the Indo-Gangetic Plain, those two areas are very important as far as our food supply is considered. And we can say they actually fall in another climatic regime. So this is what we have to keep it in mind. So that's why we should really address this problem very well. So what happened here is, accordingly, the climate change, it has about 4 to 9% impact in agriculture each year. So what happens when it happens here? There is a loss in DGP, right? So 1.5% loss in DGP has, GDP has happened. So again, this is a research which is found from CREDA, Central Research Institute for Dryland Agriculture. And here, this side, it's very important. Here you can see the negative impacts has happened in the major crops, rice, wheat, maize, and sorghum. They are the major crops, and we can say that this is a staple food used in India. And there is a very big problem here because it's having a negative impact, right? And here some like they are having the positive impact also. So what happens is the major staple food faces a problem that thereby reducing the DGP and GDP, right? So that's why we should be very cautious. So here, who is responsible for this? So anyway, whatever let it be, from the evolution onwards, from the evolution of planets itself, there was a lot of change, which has happened by the mass of the planet. So not only a human, there are some, it happens due to nature also, like the mass of the planet, the distance from the sun, the composition of the atmosphere. So these all happens for all the planets, including Earth. But the important thing is all these problems can be easily solved by us because we are having a lot of technology and other things. The only thing is, you see, even we are having ocean currents, and these two are very important. Right? These ocean currents, even though they occur naturally, So ocean currents here, what happens is the currents from the polar region may come towards the equatorial region, so that whichever countries are there nearby the coast, they will get affected, right? So this is the principle behind El Nino and La Nina factors. So what happens is whenever there is a change in the weather or climatic parameters, the ocean currents also may change, thereby determining or changing the climatic scenario of the nearby nations. That's very important. So here the anthropogenic effects actually affects the ocean currents also, and these two parameters are very challenging for us. And anthropogenic effects, as we know, it's very important to address. So here, so this is how our cities look. So whenever we see our cities, it was really a green nature like this, but urbanization has become a very big problem, whereby see this cities are being built in these green areas. So we are giving green areas and we are getting the urban region. So we should be very cautious, right? So in order to maintain our green cover, we should be very cautious. If you see the urbanization scenario of the globe here, only in the global level in 1800 only 3% of urbanites were there, but in 2023 57% is urban. The same scenario is there in India also. You see, now in India also nearly 37% are urbanites. So all urbanites in the sense they live in an urban area, whereby we are changing the environment. So anyway, due to this, there will be a rising sea level. So what happens is, due to global warming, the nearby countries, they may get affected. So likewise, there is a decrease in snow and ice content. So what happens is our Earth's temperature may rise whenever there is a reduction in the ice and snow extent. So that's why we should be very cautious. So that again, there is a changes in rainfall and snow, as we have discussed already. Yeah, so all these issues have should be addressed. So there will be increased temperature or increased temperature near the oceans, land, and other things. And whereas ice and other things, they get decreased. So this increase and decrease has to be managed properly. So it's very important. Like we have to do something for our climate change. So somebody has raised the hand. Roll number 17. Is there any doubt? No, I think I will proceed. Okay, so here when we think about this climate change, it has to be addressed in various levels. Like there are certain issues related to climate change at global level, and we are having certain issues related to national level. Likewise, we are having certain issues which is at regional level, and we are having issues which is at local level also. So at all these levels, we should be able to address. That's very important. So, and this addressing should be done in a very faster. So that's very important. So we will discuss how we can address all those problems. So anyway, we need, if you want to address all those, we need some scientific plans to save our Earth, right? So that's why what we do is these scientific experiments, not like chemistry, physics, botany, or zoology, we can't do it directly. But here what happens is we are doing all the experiments in the Earth. So this cannot be done in the Earth, and we can't do back again, or you can't make experiments there. So what we do is we just try to prepare maps or models nowadays, and we try to do all our scientific experiments in the map or in the models first. Then we test it, and then we can do it in the Earth, so that it gives a very good result. Okay, so here what we do is like, so what about the geospatial perspective for the climate change and other things, right? Any doubts, please? Okay, so geoinformatics, it actually, what does this mean? So here we know the geo means Earth, and informatics, it is the facts or data analysis, which is used by using computers. So here what we do is we collect the data from the Earth using so many by satellites or other things, and we process it in the computer, and then the information is used for various purposes, right? Okay. Okay, this information is used for whom? So mostly we collect the information and it is used for individuals, for navigators, for geographers, surveyors, engineers, and everybody use this information. And what information and how we collect is by means of remote sensing, we collect the information. Then by means of global navigation system, we collect the locational information or the position information. Then we take this in geographic information system and we process, we analyze, and we try to get proper decision, and we give it to the society. So that is how it works. And nowadays, what we do is we are having a large data, and the data should be done very faster. So that's why we get the help of artificial intelligence also. So what we were, all these four concepts we will discuss in the first session, right? Remote sensing, the GNSS, then the GIS, as well as GeoAI. So all these four, so this GeoAI is the very recent technique or tool which is used for climatic change and other geospatial studies, right? So all these technologies, they come under the common umbrella, which is called as spatial sciences or geoinformation technology or geoinformatics, right? So we know remote sensing, it is getting the information from the earth, of the earth by not without touching the or without destroying the object, we get the information. So it's a science and art of obtaining information about the object, the area, the phenomenon which is under investigation. So this maybe we will discuss the remote sensing in detail. Then GPS, it gives the navigation system, it gives the geographic coordinates in a real-time basis. So that is the real-time coordinates is important. So nowadays, sometimes we may use our mobile phones also. By using mobile phones, we get the geographic coordinates. And what happens is, geographic coordinates are very important as far as GIS or geospatial perspective is concerned. Then GIS, it is like it is a tool which is used for storing, collecting, manipulating, which we will see in the applications also. And geospatial AI, it combines artificial intelligence with geospatial data, science, and technology. So it uses this artificial intelligence they use to analyze, model spatial and temporal phenomena. That is very important. As we are discussing, as I told you, the location is very important. Whenever we think about Earth, the location and the problems with reference to the location is very, very important. So not only location, even temporal, in the sense it is important by time also. So for climatic parameters and all, we have to take like 30 years or 50 years. So likewise, for each and every parameters, we take certain years. So when the data is more, then we need some efficient system to manage the data. So that's why the artificial intelligence also plays a very important role in geospatial analysis, right? So how the spatial or geospatial research goes, this the study of geographic information, it says like how to collect the data, and the data should be collected in a very proper way. So as we know, whatever in computers, we very simply say input garbage, output garbage. So what we input is very, very important to get what we get. So if you put an input data which is wrong, then the output data also will become a problem, which will become another challenge for our decision. So how to collect the data systematically, that is very important. Likewise, how to store the data, how to manage the data, and how to analyze and visualize it is also very, very important. So geospatial technology, it refers to all those which is relevant to this, right? So anyway, this spatial sciences or the spatial technology, it includes various other fields also, like mapping, then computer-aided design, then preparing the database, then remote sensing, then surveying, as well as photogrammetry also. Photogrammetry is the art of taking photos from the aircraft so that it is taken systematically and it is used for analysis. So for example, if there is a flood at a place, so immediately we can't say that the satellite may take a picture there at that specific time. So what we do is we just make an aircraft to fly over, and we take the photograph from the aircraft, which is called as aerial photograph. And from that photograph, we do the analysis immediately, and immediately we say that, okay, this much area is being flooded. So we know that it's a flood, it may they be there for 1 or 2 days only. So in the third day, everything will become normal. So, but the affected area has to be mapped properly at the proper time. So that is also yet another field in GIS. So anyway, whatever has location, that becomes spatial data which has to be analyzed properly, and we can give us a from geospatial point of view. So anyway, for spatial data, this grid coordinate is very, very important. So what we say that latitude and longitude is very, very important, and the location, description, distance. So these are all the properties of a spatial data, right? Okay, so the spatial data is the data which has latitude and longitude, and the attribute data is the data which actually explains the spatial data. So, so attribute data is also very, very important as far as our decision is concerned. Whatever attributes can be attributed to the spatial data can be managed in terms of a database management system, and it can be analyzed or queried in such a manner, right? Okay, so here we can say that it is a GIS, it's a toolkit which can manipulate spatially. That is very important, manipulate spatially. For example, we can calculate the distances and we can say the relation between them. Likewise, we can change the projection as well as the scale. Maybe we can prepare a map at local scale, and even we can change it for a country, and then we can analyze and we can give it for a country level in a national way. So the scale changing also can be very easily done in a GIS. So likewise, if we want to integrate data from various sources, that also can be. So anyway, manipulating spatially is very important. Likewise, we can do the analysis also spatially. So analysis part also, we can say like it can be done like we can do a quantitative analysis. So not only quantitatively analysis can be done. I'm doing some case studies where even we see we can go up to regression or whatever statistical, geostatistical analysis also can be done in the by using this data, right? And we can do some exploratory data analysis likewise, and qualitative analysis also can be done. So everything is done spatially. So that means everything is done with reference to latitude and longitude. That is very important. Then visualizing the data in the form of maps or in the form of tables, graphs, some animations, and some even we can even join some videos or some audio facilities or even some photographs to that point, and then we can explain. So that's how maybe you see multimedia GIS is also there. So accordingly, visualizing data also becomes a very important thing. Okay, so the approach, it explores the data in both ways, even a conventional way as well as at a geographical way. So it allows us to think about the implications of the location. So maybe the parameter will be there, and location plays a very important role there. So it becomes very, very easy for us to think in such a manner. So likewise, it allows us to think holistically. Maybe we can include so many parameters, whatever parameters which is determining the event. So we can think at a holistic manner. Likewise, it is it cannot be restricted to some facility. Like you see, there are so many packages now, GIS packages, where we can customize ourselves and we can change and we can even use it for our any function. So likewise, it can. So we can say that the spatial analysis or geospatial perspective, it depends upon the people who use. It depends upon the thought process of the people. That is where so accordingly we can customize the software and it can be used. So there are so many advantages accordingly. And sometimes what we do is even the humanities part of it also can be included. So anyway, GIS handles the spatial information. And the information, why we say that it is spatial information is, it is actually referenced by the location. So that means the reference in terms of latitude or longitude is given to the given to the data, right? And it can make connections also. It can make connections, and we can ask so many queries. So we will discuss that. So for example, this is not so new. Actually, it started from 1854 onwards. So GIS concept, it actually started there itself. But nowadays, after the advent of computers only, we were very easy. It was very easy for us to maintain. So actually, Dr. John Snow, he was the one. What he thought was there was a cholera epidemic in London, and he actually got the when people came for treatment, he actually located the addresses. And when he located the addresses, he found there is some relation, and he found that some spatial concept is there in behind. So what he did is immediately he just put the water pump, right? Water pump in that. Then he found out that wherever there was water pump, there was a cholera fatality. So accordingly, he found out that, okay, cholera is actually formed due to water, and then they started to experiment. So this is how it started. So likewise, so many solutions for the problems may come from spatial point of view. Likewise, the history of GIS, it started from CAD or digital cartography or whatever. From maps only it started, and they connected maps as well as the database the management system, so that it is connected. And certain decisions can be done. So the historical development started from when Ptolemy, he actually started the world atlas with 100 maps. From that time onwards, the analysis of GIS came, the concept of GIS came into existence. And as I told you, maybe manually, if we do analysis, we can do an overlay of 2-3 maps only. But nowadays, when computers and when AI come, we can manipulate a lot. So we can see in detail. So anyway, GIS is having 5 components: hardware, software, data, methods, and people, right? So it depends upon all those. Then the first thing is, when we capture the spatial data, it's very important. Like the data can be put like scanning. You can scan the data and we can have the maps into a system. And sometimes we digitize and we convert the hard copy maps to soft copy. So similarly, like typing our letter and making it. So similarly, we can convert it into lines, polygons, and points by digitizing. Such type we can capture, and then we have to georeference. That is the first and foremost thing which we give in GIS, because it has to know its location. So initially, when we scan or when we digitize, the system may not know the location. So we have to train the system by giving the lat long, and that process is called georeferencing. Once georeferencing is done, whatever data which is georeferenced, the system can identify that this is and it can relate the various data, right? So maybe, for example, if this is an example of a georeferencing. So this is a map, and here maybe you see a map with some lines. Here we can put some points with some numbers, right? So this is the latitude and longitude, and we say that this corner is this number, and this corner is this latitude and longitude, and this corner. So likewise, if you give four latitude and longitude, then all the features of this map will have this lat and long. So this is how we train the system, by giving the georeference, right? So this is very important. Then only, if I give 10 or 15 maps, all the maps has to be georeferenced, and so that it may lie one over the other, and we can have a spatial relation. We can study the relation among those layers or among those maps. For example, so this is our this is the satellite view of our university, Madurai Kamaraj University, to which I belong. And here actually the satellite will take the data, and what happens is, here we will know like Madurai Kamaraj University with a postcode. But you see, again, in GIS, the system has to understand that it is at 78 degree east and 9 degree 56 degree north. So when this is the case, then this data is being georeferenced, and so that we can analyze, right? So that is very important. So there are certain characteristics of the spatial data, like you see, geometry is very important. That means the shape of the building or anything, whatever. So here, whatever the lines which represents here, it is in a scale where I can show you in a small screen. But the same thing can be extended, and it can be put in the ground. So it will actually really overlay in the ground. So that's the importance of the spatial data with the georeferenced one. So likewise, the shape of the relief, the course of the river, all whatever is there in the earth in a three-dimensional figure will be there here in a two-dimensional. So there will be a conversion. Then that conversion is called as projection, right? Okay. So after this is happening, then we can create a topology. Topology in the sense, you see, it's like we can say how it is connected, what are within, what is adjacent to, and what is north of this area. So such type of questions we can say, like within the campus, or opposite to some building, or north to some station, or adjacent to this road. So these type of queries can be asked to the system, so that so let the data be a small village or a global level. So at various levels, the database or GIS will be capable of answering. For example, you see, we can have like road network, then vegetation inventories, soil inventories, census results, municipal boundaries. So so many. So I have given like 3 dots, whatever it can be. So all these are the spatial data examples. Like if you have a road network, maybe there is a analysis in transport geography telling that maybe we can know like graph theory. By using graph theory, you can say you can analyze the road network and you can find out those places. Based upon that theory, you can say that there is accessibility and other the connectivity and other parameters can be analyzed in a scientific manner, and we can give proper decision to the decision makers. So these are the places where the road network is not good in terms of accessibility, and these are the areas where the road network is not good in terms of connectivity. So likewise, we can have so many analysis behind this. So and the I mean, help can be given to the decision makers like this. So likewise, for example, climatic readings are there. So maybe as we are discussing, so the climatic readings can be taken, and then we can say when the temperature rises, what will happen to the wind direction, and when there is a temperature fall, what will be the result of what will be the result in rainfall, and likewise what will happen to the agriculture which is present over there, or you can say like what should be the crop which I have to cultivate in the next season. So such type of analysis or predictions or forecasts can be given based upon this climate readings. So these are the base which is being fed up into a GIS, so that it will help us to give a lot of help to the decision makers, right? Okay. Then coming to the socioeconomic data. Hello, sir. Oh, sure. Oh, that's what. Okay, sir. I will. Shall I come out and then join? Wait a minute, sir. Yeah. Wait.
Hello.
Now is it visible to you?
हाँ मैम, आपको वो साइड शो कर सकते हैं क्या पावर पॉइंट का?
Yes, I have slideshow only.
यस।
Is it visible? The slide shows GIS components data.
Yes, madam. This is visible. Slide number 15. This is visible.
Yeah. Then what is the problem? Earlier it was not visible, huh?
Yes, yes. Earlier it was not visible. That was not moving.
Oh, I am sorry. You should have told first itself, huh? Okay. Now I think it's okay.
Yes, ma'am. It's okay now.
Okay. If there is any problem, let me know, because I couldn't see that. I couldn't know that you're not. It's not visible for you. Okay.
Okay, definitely, madam. Next time we will inform you.
Yeah. Okay. Sorry for that. Okay. So anyway,
No problem. No.
attribute. I think I have made you understand a little bit by talking, at least. Okay.
Yes, madam. We have understood earlier.
Okay. So anyway, attribute data, it is the information which is found at a particular location. So maybe, for example, if you take soil, so this is the layers in GIS: topography, hydrology, or land cover soils. So if soils is taken, we can say for say attribute data can be texture, type, pH, erosion potential. We can have n number of parameters. Likewise, land cover also it can have like n number of parameters. So whatever layers we give here, all the attribute data can be n numbers. So in n numbers data we can take and we can do analysis and we can come to the conclusion, or we can do a decision based upon all those parameters. So here, for instance, for figure, I have given maybe 4 layers, but we can have so many number of layers, maybe 50 or 60 or whatever. And each and every layer may have so many attribute data also. So that also can be analyzed properly, right? Okay. So anyway, when we think about hardware and software, the computer systems, it should be very we should have a very sufficient processor. The memory should be good. Likewise, there should be high resolution color graphic screen, and that the quality of this also should be good. So we should take proper, like the data input and output devices also should be very good. So whenever we get a system or whatever for GIS analysis, all these has to be taken into consideration. Is my slide moving, sir?
No, madam, it is 15. It is 15.
Now we have given like GIS and analysis methods. Is it visible for you?
Not yet, madam.
Oh, my internet is okay only. Now has it changed?
Not yet, madam. This is 15. 16 is not visible yet.
Oh.
Now it is 47, ma'am.
Shall I, I am not going to slideshow. Shall I present like this? Okay, it is GIS analysis and methods, huh?
Yes, madam.
Okay. Maybe very slowly, I think it's moving. Okay. So anyway, when we do analysis, it's like, you see, already we have given the data and we can get new information also from the existing data. For example, maybe if I give the data, identify all the areas within 500 meter of a lake. So this is the query which I am giving to GIS, and I can get the data. Okay. So this is the lake, and these are the settlements, which is 500 meters inside the lake. I mean, inside maybe the buffer, and we can just pick over those settlements and we can do. So such type of query or new data also can be got by using this GIS, right? So that's where GIS stands. So likewise, we can do a lot of spatial analysis, like a set of techniques. which is used. Then it can be used for decision support also. Right. For example, you see, we can have like, how many schools are there in your village? So that is a normal questions which we can ask. But the thing is that any database can give you, or even we can have a list and we can verify. But the thing here is like, how many schools are within 5 kilometers of travel by local bus? So you take a local bus and within 5 kilometers of travel, how many schools are there, and which is having all the basic facilities for the children in the village. So when this is the question, then we need to consider the child population, the local bus route, its accessibility, and we should know the school location, and whatever facilities is there in that school also is needed. So when such type of questions are asked, or such type of queries are asked, then we need a spatial relationship, and GIS is very much needed. So this is the question which is asked by a decision maker to maybe to increase the number of schools, or to increase a basic facility for the village schools. So this has to be addressed, right? Sir, and is this slide visible?
Yes,
Spatial
madam, this is
example.
visible.
Shall I proceed? Okay.
Yes, yes, definitely.
Okay. Okay, so this is how it happens, right? So it actually links spatial as well as attribute data. And we can, as I told, we can visualize the data by using different symbols also. And these map symbols are also standardized, and everybody who looks at the map will understand the symbols, and they can give the analysis. So in a similar manner, GIS also, it's having different symbols which can be used for different attributes, and it can be used. So this is the this spatial analysis is a unique feature of GIS. Not only spatial analysis, like we can have visualize the earth in a three-dimensional manner also. Nowadays we are having a lot of softwares, photogrammetry softwares and all, which will actually give the three-dimensional view of the earth. Maybe we can have the satellite data there, and we can analyze, and we can have a very we can have like expertise from all the fields, and we can have a table and we can discuss, and we can come to a decision. So that is very important. So the databases which are in tables, actually it's very difficult for us to understand what the table says. So but when it comes under a picture, or when it comes under a map, then it will become very easy for us to understand, and it will be very easy for us to communicate, and it is very easy for us to make a record of it. So that's why mapping is very, very important. For example, you see, this is another map. It shows like there is the poverty will be there, and there is a polluting company, and we can say that, okay, what are the percentage of people who are having below poverty line, and we can ask the system to just query, or say or highlight these peoples. So likewise, the conventional database, it says who, what, when, why, and how. But when it is GIS, it will like what is at that location, what is it, what it refers, and what has changed, what is the trend of the change, as well as what are the spatial patterns which exist, and modeling also, how we can model. So such type of and we can do some forecasts also, what how it is it can be forecasted. Such type of analysis also can be done. So anyway, this GIS, it can be put like, the data can be of two types. One is raster, that means we can say that it's a satellite image, mostly satellite image, aerial photo, which is in the form of pixels, or it can say that picture elements. So it will be like something like square boxes where the information is stored. Or it can be like vector, which is called as the vertices, where it is stored in points, right? So the points, maybe you can say line is also a collection of points, like as polygon is also a collection of closed line. So anyway, it is like it can be stored in a grid, or it can be stored in points like X and Y. So when it's stored in grid, then it is called as raster image. When it is stored in points, then it is called as vector image, right? So we can say that this models, it is the raster model and vector model. And raster model gives a grid-like appearance, like as in image files. And vector model, it gives like, you see, X and Y, 7, 10, 9, 8. So like that point, you see, it is given like 2, 2. But a line, it is represented like 1, 2, 3, 4. Wherever there is a change, then there is a point, right? 4, 1, 5, so this is a collection of points which represents a line. And here there is a collection of points which represents a polygon. So anyway, both models are there, and both models are having its own disadvantage and advantages. So what the thing is, we are modeling the real Earth, we are having it in the system, and it is converted into digits, and these digits will be stored in the computer, and we can forecast, or we can do some change there very easily, so that it can be implemented in the real world. That is all. Okay. So anyway, it forms a very good geodatabase. JS forms a very good geodatabase where the analysis can be made very efficiently. So actually here, as we say, this analysis or these tables, whatever we have in the attribute data, is directly connected to the map. So what the thing is, we can have a query in the table, and we can ask the system to reflect it in the map. So that is also possible. And from the map, you can have a query, and we can take it from the data. For example, I can select the cities which is having more than 5 lakh, more than 50,000 population. So if I give a query, maybe I am having a database of the whole country, and I am asking the system, telling that please select the cities which is having more than 50,000 population and less than 1 lakh population, for which I can plan for some schemes. So just immediately, if I ask the query, immediately at a minute, the database, it may collect, and it will give you it will highlight the cities, and I can immediately I can make a map telling that these are the cities which we have to concentrate. So such type of query manager is also available. So likewise, I can have so many, we can have whatever. So this is all user specified. So whoever uses this data, they can determine their own layers, they can determine their own themes, and they can analyze. For example, layers in, this is a image which is showing the municipalities of America. Okay, so likewise, we can have census tracts. Similarly, we can have like the data for a country, then a state, then the district, then tehsil, then block, then village. So accordingly, we can have the data for a nation up to village level, and all those attribute data can be given. For maybe, for example, the village level population can be attributed first. Then I can immediately ask, okay, these are the villages which belong to a state. So I can immediately I can ask, how many population or how many households are there in this specific state. Then it will immediately query, and it will do an analysis, and it will add all the villages which belongs to a particular state, and we will get the population data. So not only for population, whatever data we give, I can give n number of queries, and I can get answers. So here, first it was municipality, then census tracts, then lakes and rivers. So these are the layers which I have kept, because all those, they overlay because of the concept that we have georeferenced. So that's what we discussed. For the first and foremost thing in GIS is we have to do a georeference. We have to tell the system that this belongs to this latitude and longitude. So when that is the case, then everything will get overlaid, and we will get one by one theme, one over the other. So what happened is here, census tracts and lakes and ponds are there, and I have put the polluting companies also. And the next layer is schools. So all those are in the same project, and we are just trying to get, like, you see, I can give a query telling that what is this the heavy polluting industry. And I can ask the system, if I just ask the system, what is the census tract to which this polluting industry belong? So it will immediately answer, oh, this is the area, and it will show in the map. So what I want to emphasize here is whatever data we give, it is directly connected to the map, and immediately you can have a display from the map as well as from the table. And now I can ask another question, a new question, which is not at all in the database, telling that how many schools are there in the vicinity of 1 kilometer from this highest polluting industry. So it will just pick up and it will say that, okay, 6 schools are there in the vicinity of 5 kilometers from the high polluting industry. So this is how queries can be made in the JS database, right? And n number of queries can be asked. So queries, and we can give some restrictions also if this and not. So many Boolean logic also can be used and queries can be developed, right? And yeah, this is the picture which is showing. You see, this is the buffer line.
Madam,
I think it's visible.
yes, madam. Same slide number 47 is visible, appearing on the screen.
Actually,
And yes, can you make this slide large, ma'am?
I have to put screen share on. I mean, slideshow on.
Yes.
Is it okay?
Yes. This is
This
slide
turns
number.
data into information.
Yes, information. Madam, there is a symbol of lotus. If you click there, this slide will be very large. Now it is so small. Some participant have requested that please request it to you.
Actually, it is in slideshow only. When I click no, that slide is changing, but it is not coming to large.
Okay.
It's changing, no? See? It's changing.
Yes. Now this is 71 now.
Yeah, it's changing, but the thing is, see, sir.
There is below lotus symbol. Some participant told me that we can make it large.
Hello, sir.
Yes, madam. Boli.
Hello.
Yes, madam. Now 70, slide number 70.
Yeah, it's slide number 70, right?
Yes. Continue, madam.
Okay. Shall I continue?
Yes, continue.
I don't know whether there is problem in sharing. Stop share. Now, how is it, sir?
Madam, yes. Now it's okay now.
You just ask that participants whether it is okay.
Yes, madam, it is okay. Now it is large.
It's large.
Right.
Okay. Okay. So here actually we can see the schools within 2 miles of the top polluting countries. I mean top polluting industries. So this information is a new information for me, so that I can take special steps for these schools or whatever. So it will be very useful for the decision maker, right? Okay, so anyway, when this is the case, the need for information is very important, and I should get very real-time data. That's very important. So the data should be real. That is one thing. It should be unbiased, and we should need real-time information also. Every now and then, maybe I can say every hour I need the information. So we know weather conditions, they change within us. So within us, the information also I need it. That's very important. So that's why what we do is we have remote sensing technology with us. What we do is we keep an eye in the sky. So that is how we can describe the satellite. So the satellite is kept in the sky so that it looks at the earth at every point of time, and it gives the information very properly, right? So remote sensing technology plays a very important role in giving the information at various levels. So we are discussing like we need information at local level and we need information at global level. That is one point. Then the second point is we need information at a particular hour, and we need information at like for years together. So when this is the case, then remote sensing technology plays a very important role, right? Is this audible? I mean, is the screen visible for you, sir? For
yes, madam, the screen is visible and you are audible too. It's very well.
Okay, good, sir. Good, sir. Okay. 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 So this eye in the sky. One more point is there. and this is unbiased. So we need a real-time information, or real information means we can very easily say that, okay, the satellite data is unbiased data. There is no way of biasing. So whenever we define the satellite and we fabricate the satellite, and when it is sent to the space, then afterwards there will be nothing to do with the satellites, or you can't change anything. So whatever comes in the as a data, we have to use. So what happens there is there will be unbiased data. That's one thing. Second thing is it forms a very systematic record of the data which we get. Either it can be a global level, or national level, or regional level, or local level. So it becomes like a real record of the data which is there. So we can get a real-time information for all those analysis which we have discussed earlier, right? Okay, so now when we think about satellites, there are two types of satellites, you can say, geostationary and polar orbiting satellites. Geostationary satellites, they will be seeing at one point of one location at one point of time, like every time, and maybe we can say that it is oriented with the Earth's movement, Earth's rotation and revolution. So it looks at a certain position. Maybe if India is sending a geostationary satellite, it will be totally looking upon India. So likewise, every country have their own. So these are the satellites which is used for our purpose, like climate change and other things, right? And we are having polar orbiting satellites also, something like this. It goes from north to south pole, and when it moves like that, Earth is rotating so that we get the data for the whole globe. So this is the animation which is showing the polar orbiting satellites, right? So these actually this polar orbiting satellites, they give the information of the whole globe, or they record the information of the whole globe, so that what happens is we can use it for sustainable development. If you want to say a particular area which is used for certain purpose, we can have a record of that. So for that, actually, this polar orbiting satellites are used. So actually, as well as when we think about climate change and sustainable development, most of the sustainable development applications depends upon polar orbiting satellites, whereas the climate change parameters, they depend upon the geostationary satellite. But in some applications, they take vice versa also. But majority of the applications of climate change, they use geostationary satellite data, and the sustainable development applications, they use like the polar orbiting satellites, right? Okay, so here the very important thing is it comes in electromagnetic radiation, like mostly this polar orbiting satellites or whatever, it depends, it actually takes electromagnetic radiation into its into consideration. Here we know that a very small part only is visible to our eyes, but whatever we fabricate as a sensor and whatever we keep it in the space can determine in the invisible part also. That is the very good part of remote sensing, right? So this infrared rays, this invisible part of the spectrum, and certain small area of ultraviolet rays is invisible to our eyes. So even we can get information from the invisible part, and we will discuss why it is needed. And visible part, we know even with our eyes we can see, but still remote sensing plays a very important role, so that this visible part data is being recorded in a very systematic manner. So why we do in a very simple example is our X-rays. So X-rays, they are not visible to our eyes, but when we use X-rays, we can see the fractures in our bone. But external appearance is also very important. So visible part, then maybe the X-ray will not say who the person is, but the external appearance only shows who the person is. So the visible part of the spectrum is also very much useful, and the invisible part of the spectrum is also where, as X-rays reveals our fractures in the bones, here infrared rays also reveal certain things, certain features, and even ultraviolet region, a small part of ultraviolet region also reveals certain regions like the radioactivity or some properties of minerals is also seen, right? Okay. So for example, this is a very simple example. When we use a normal photograph or normal visible photograph, this stadium, the center of the stadium, you see, this is green in color, so that we will misunderstand that, okay, the central part of the stadium is actually grass, which is a natural thing. But it is not so. You see in the second photograph, this stadium, the lawn of the stadium is a is like, you can say that it's a manufactured one. It's not natural grass, because that is seen in green as such. See, but the all other natural vegetation is seen red in color. So what does this mean is, the natural vegetation is actually able to reflect more of infrared, so it is seen in red color, whereas the artificial lawn is not able to reflect infrared, so it is seen again in green in color. So this is how certain unrevealed information can be got. So this is an example, and here we know that this infrared is totally dependent upon the it is dependent upon the chlorophyll content of the plant. So what happens is, whenever there is a change in the chlorophyll content, then the infrared radiation may get affected. So we can get more information about the vegetation when we are using infrared radiations, right? So that's why we do the remote sensing process in the invisible region. So anyway, as we see in this slide, there are 1, 2, 3, 4, 5, 6, 7 layers where it is put it into like different parts, and it's being represented. Like in the visible itself, we can have 3 different range, like blue, green, red. Then in the infrared, you can have 2, 3 ranges, like near infrared, mid infrared, and far infrared. Then we can have microwave data also. So all those can be recorded in different layers, and we can have like we can do some analysis based upon that. For example, here you can see the reservoir, which is seen in various bands of visible spectrum. Like the band here you can see this is the blue band from 0.45 to 0.51 micrometer. The reservoir is seen like this, but here you can see like the reservoir is seen in a very dark black in color. The thing is, if I want to map this reservoir, then I have to go to this band. That means, you see, the band which is from 1.55 to 1.75 micrometer of the electromagnetic radiation, right? But if I want to see the differences within this reservoir, maybe I am very much interested in studying the sedimentation rate over here. Then you can see the sediments difference in this point. So I have to go to blue-green band, right? So blue-green band is very much essential to study within the reservoir. And if I want to do a mapping of that, then I have to go to infrared range. So this is how the bands of the spectral range of the EMR is being generated. So anyway, if we take blue, green, and red alone is visible to us, and our display device like the computer or whatever is dependent upon this blue, green, and red. Here what we do is, if we want to see this infrared, if you want to get the data of infrared region, then what we have to do is, we have to take the green and we have to give for blue gun. And if you want to take the red, and we will give for green gun of the display device. And we take the infrared region and we give for red gun of the red gun of the display device. So what happens is, accordingly, if you give, you will get a area, or the vegetation will be shown red in color, the water will be shown blue in color, and other things, so that we get a very clear picture of the vegetation which is seen over there, right? Okay, so likewise, we can have different color composites like say 3, 2, 1, 4, 2, 3. So these 3, 2, 1, 4, 2, 3, these are all representing the bands which is present over there. So this is a false color composite, and this is a true color composite. So the why I have shown this is, for example, here you can see all are green, right? All are green. There is no difference. But when we take the false color composite, standard false color composite, there is difference in the red. Right, there is a lot of difference in the red, so that we can very easily we can easily map the types of fields which is present over there, right? So that's very important. Then only I can very properly, I can say that, like you see, this is one field, and these 2 fields belong to the same crop. So crop type mapping and all can be done in the standard false color composite. Why is this here? It depends upon the infrared radiations, infrared radiation which is being given by the crops. Okay. Okay, so here actually due to the solar or even the sensor can become a source, it will get reflected within the various features, and it is being recorded by the satellite, and it is given distributed for analysis. So this is the stages of remote sensing, right? Okay, so here spectral reflectance curve and spectral signature is very important as far as remote sensing is needed, right? It's a key, right, to find out what type of landform is there. For example, agricultural field will see in such a manner, a rocky terrain will be seen in such a manner, and the mangroves will be seen in such a manner. So this is how the signature refers. So for example, this is the signature of water, where there will be a maximum reflectance in the blue-green region, and for vegetation, we can see the maximum reflectance is in the fourth band. That means it is in the infrared region. That is 0.7 to maybe 0.9 micrometer. You will have the maximum reflectance of soil and vegetation. But the soil, you see, gradually moves, right? Gradually it goes up and it stabilizes at one point of view. But for vegetation, it goes up, it comes down, again it goes up, then it comes stable, and again at 1.3 it again comes down, so that it maybe, you see it in the picture also you can see, when you take at this point, like in this particular wavelength, the vegetation will show its maximum reflectance. But when we take at this point, like in 1.3, then the reflectance may be very less. Okay. Is my slide visible, sir? That spectral reflectance curve?
Yes, madam. Yes, slide
Thank
is visible.
Okay, thank you. Okay. So this is like, see, the white surface reflects equal amount of radiation, right? For all wavelengths of visible light. So when we take a white surface, there will be, so that's why it's white. It reflects equal amount of blue, green, and red. Whereas a green plan bin, see, it reflects less red and blue than green. So that's why it looks green. So this is how the same thing, but the plants have a unique property, like it can reflect more infrared, which is dependent upon the chlorophyll content. So that is very, very important, and that's why it's used in remote sensing. For example, okay, we will see in the next slide. So here actually we can see urban, see green will be less, red also is more, some more greater, and infrared is more greater. But if you take a river, see green will be more, and red also a little bit more, but when we go for infrared, it is coming down. So that's why water body shows a very black or dark tone in satellite imagery, right? So, but if you take pasture, see pasture, forest and all, near infrared is dominant, whereas the other regions are come. So if you want to study something about forest, pasture, or chlorophyll, then we have to go to near infrared region. But if I want to study about lake or water body, then I have to go to the blue region. So that's how we select various. Okay. So here, for example, different types of minerals also shows different types of spectra. So this is where geochemist plays a very important role. So the whole globe, we can have an image, and then we can identify the type of minerals or ores which is present there in the Earth's surface. So that is an important part. Right. So here, this is another application where, or the spectral signature, where it shows the moisture content. For example, you see this red dotted lines shows that this area is having 66% and more, 66% more moisture content. And this brown line shows less than 40% of moisture content. So, so we can say that when moisture content is more, the reflectance might be less. When moisture content is less, the reflectance might be more. So by basing this percentage, we can maybe by basing this reflectance, we can calculate the percentage of moisture content in the plant. So we can say that, okay, when the field shows 40% of moisture content, then we have to we have to irrigate that field because the plant is going to starve with water. So this is how it is used for precision agriculture. So not only for moisture content, even such type of analysis can be done for the nutrient also. Maybe if the field is suffering from potassium deficiency, then it will show its own change in the reflectance pattern so that the field can be supplied with potassium fertilizers. So in such up to that level, we use remote sensing for our agricultural productivity or whatever. Right. Similarly, but the thing is, we have to take the particular band for particular analysis. So that's where the systematic study or scientific study is needed. For example, here in this image, you can see three pictures, 1, 2, and 3 of the same area taken in the same time. But you see in the first picture, this river, which is shown as blue, which I have marked in the blue, is not at all seen, right? But you see, the same, the area which is marked in green, which shows the vegetation, is not at all delineated in first two pictures. So if I want to delineate this river, then I have to take this thematic mapper band 4 of near infrared range. That means it ranges from like 0.76 to 0.9 micrometer. So this band alone we have to take for delineating the water body, not this band. If you take band 3, we will get confused so that we can't delineate the water body which is present over there, right? So the band selection is very, very important. According to our applications, we have to select. Okay. So anyway, the band or the EMR range which we are going to use for our specific applications is very, very important. Okay, so here in this slide, we have to think about the types of remote sensing. So types of remote sensing can be based upon like source of energy, source of the platform, the EMR range. Right? Source of energy can be passive or active. In passive remote sensing, we use sun's energy, whereas in active remote sensing, we use the sensor's energy itself, like the satellite's energy itself as a source. So here, example, radar and LiDAR. Here, the normal optical remote sensing, which we send as polar orbiting satellites, is of passive mostly. Then based upon platform, we can use aircraft or we can use satellite. And nowadays we are using drones or unmanned air vehicles for remote sensing process. And based upon the EMR range, it is like visible range, infrared range, microwave remote sensing, thermal, radar and LiDAR, that is determined by the fabrication of our sensor. So these are the types of EMR range. Then hyperspectral means only we can say that EMR range number is more. So maybe we can talk about 4-band data, 7-band data. Here in hyperspectral remote sensing, it might be hundreds of bands. Whereas in spectral remote sensing, it can be thousands of bands. So seeing the information when the number of bands is getting more and more, it can be used mostly for very minute applications. Like you see, when we are using hyperspectral remote sensing, we can use it for finding out the minerals in the soil or the plant deficiencies, plant nutrient deficiencies and all. In spectral remote sensing, maybe yet another applications can be used, right? So anyway, that is an R&D process. Still no sensors has been put in space. But for hyperspectral, we are having a lot of sensors and the data is also available. Okay, so this is how we see the globe. As I told you, global issues and local issues. So for global issues, we will be seeing the data of 1 kilometer resolution, which is by NOAA AVHRR. And for local level, we can use ICONOS data, which is like 1 meter resolution. So we can say this will give global level, but the information which we get will be less, but it covers a larger area. Here, it covers a smaller area, but the information which we get will be more. So according to our application, we can use the different spatial resolution also, right? So this is how, like, this is a 30-meter resolution, which shows like this is a agricultural field. But when we go for ICONOS MX data, here you can even count the number of trees over there in the field. So according to our application, we have to choose the data. Maybe if I want to do a global level analysis, then I have to go to NOVA AVHRR data, which is of 1 kilometer resolution. But when I want to do a local level analysis or a field level analysis, then I have to go to ICONOS or more resolution. So even I can have data up to this resolution or more than this also, so that the data is very clear. Okay, and this is data which is given by drone, and we can see the drone here, and the picture in the background is taken by drone. So we can even count the number of cars in the parking lot, and the parking lot, we can just find out the gap areas, and we can say the customers to park in the first line, second or third. Likewise, we can give the parking lot number also. That is one point. And the second point is sometimes if there is a natural calamity, maybe if I get this data with me, I can very easily count the number of vehicles which was there in this parking lot and it had been damaged. So from an insurance company point of view, immediately I can have a database which is an unbiased data which says you the number of cars which is there in the parking lot. Likewise, another analysis is there. If a businessman sees this, maybe he can say, okay, if we want to get a dealership, then he can go to the parking lot like this, and then he can say, oh, how many Maruti Suzuki is there, how many Honda company car is there. So accordingly, he can very easily analyze, and he can say, in this parking lot there are 1,000 vehicles, and out of which nearly 300 and 350 vehicles belong to Maruti Suzuki. So I can have a dealership of Maruti Suzuki. So such type of analysis can help the businessman also. So in all places we can use the data. Okay. Okay, as we have discussed here, the different bands are there which can be used for different applications. So mostly here blue, green and all refers to the water applications, and when we go for near infrared bands, it goes nearly for vegetation analysis, and when we go for mid infrared band, it is mostly used for mineral and rock identification. So all these are very, very important, right? I'll show you a few images. So this is an image which is showing the forest area. This is an image which is showing the agricultural area at various resolution. Then water body will be seen like this. A reservoir will be seen like this. So these are this is an urban area, closely packed urban area with a road with a very congested parking area. Okay, so this is all about the polar satellites. Then coming to the geostationary satellites. So geostationary satellites, as we have discussed, it will be located at a certain area, and mostly these satellites are used for communication and weather data. So which is used for weather. So most of the weather satellites, they use again the data, but it is used mostly for okay. So the weather satellites, they were launched before polar suborbiting in 1960 onwards. TIROS was the first satellite, and after that, so many satellites has been launched. And today, we can see a number of satellites in the space, which gives the information to all the countries related to that of their weather conditions. And this is the meteorological satellite, which is which belongs to which give information related to meteorology, right? And we can say this is there is a timeline showing from 1982 onwards. INSAT first 1A was launched in India, and there are so many satellites up to SCATSAT in 2016. All those information we can see, like INSAT series, so many INSAT series are there, which gives the information related to weather, climate, as well as it is used for communication satellites, right? Then we are having OceanSat again, Kalpana, again, that is an INSAT series. Then Saral, all those SCATSAT. So SCATSAT is a active remote sensor, which which gives so many information related to weather. So all those are used for meteorological purpose, right? So anyway, when we take meteorological satellites, they have so many systems like visible imagers, then infrared sounders, microwave imagers, microwave sounders, scatterometers, radar altimeters. So this is at another area where it is used for mostly for climate and its other products. Okay. So there are here also again there are certain bands which give information about the cloud top, sea surface, land surface temperature, then the pollutants which is present in the air and all. And there are so many types of satellite data also, like imagery, then a satellite atmospheric wind, which in the next session I will show you. Right. And we can have so many applications. Maybe we will discuss in the next session, all those. The satellite atmospheric winds, the surface temperature, wind speed, then precipitation estimate, then cyclone intensity, then all those we will discuss. So this is all about the remote sensing part. Then coming to the subsurface part. So even in subsurface, we do some remote sensing methods and we find out what is there in the subsurface by using ground penetrating radar. This is again a radar instrument where the receiver itself will send signals to the subsurface and it will get the signals back and we can find out what is there. For example, we can have a subsurface model of a city, like maybe we can have like whatever is going in the subsurface, like pipeline or whatever, that can be probed from the, even without distracting. That is the very important thing. Without distracting, we can probe what is there inside, and then we can do GIS and we can find out, okay, how many. So usually GPR, they reach to the depth of 100 feet. So here GPR, they actually employ radio waves from 1 to 1000 megahertz frequency range, and then they will map the structures and features buried in the ground, where it is used for non-invasive exploration, right? So here actually this GPR, it actually takes the dielectric constant into its consideration, and accordingly we will so each and every feature or each and every object in the earth has its own dielectric constant. Like air has 1, glacial ice has 3.6, PVC has 3. Likewise, you see, concrete has 4 to 11. So likewise, each and every materials, they will have their own dielectric constant. So GPR gives the dielectric constant to our, it will measure the dielectric constant from the interior and it will give, so that we can find out if it is 6, then it is sandstone. If it is 4, then we say that it is granite. If it is 3, then we say that it is a PVC pipe, right? So likewise, we can very easily probe the interior surface. So this is not that much used in climatic studies or weather studies now, but still I want to show that this also is used for GIS, right? So applications of GPR is totally related with the construction field. So this is how the GPR images will be shown. So here will be parabola, and this parabola, it represents the electric constant or whatever, and the rays of parabola tells you how deep this is, right? So it is like 220 mm, 6, how much deep the buried feature is or buried object is. And then we can say, like, you see the distance, no, the distance between these two arms, they say the diameter of the object. So this is how we can determine what is there in the subsurface. So not only in the surface or not only in the atmosphere, even in the subsurface, we can do some analysis. So analysis, and we can find out. Then coming to the global positioning system, this is the third technology which is used in GIS, and this gives the information of location information. For example, in this slide, we have placed a point, and if I remove this point and if I ask to place in the same point, then it becomes very difficult. So this is how when we are there in the globe also, it will be very difficult for us to locate. So that's why what we do, if I want to locate, I can put a graph like this, X and Y. So this represents, like, it says that this is 4,5, 4 in the x-axis and 5 in the x-axis. So even though if I remove, then I can place this graph and exactly say, this is what georeferencing says here also. Here, by using latitude and by using longitude, we can locate a position. So for that, maybe in all the time, we can't have a graph sheet or whatever, it's impossible. So what we do is we have a set of satellites. This is a simulation. So showing the GPS satellites in the space. So this is the GPS satellites, which is placed like 20,200 kilometers from the Earth's surface, and it is there orbiting in 6 orbitals, so that each and every location in the Earth, so center is the Earth, each and every location in the Earth shows a visibility of at least 4 number of satellites, because 4 number of satellites is needed to get the latitude, longitude, and altitude, which are the 3 unknowns. And the fourth satellite is needed for time correction, right? So because the concept is based upon time. So here in the orbits, there will be 4 satellites, which is coming around, and totally 24, and now it is like 32 or 33 satellites in the space. And here the distance between the satellite and the receiver will be at one place, and from the receiver, when we switch on the receiver, it will get the distances of 4 satellites, right? So from various places, and by the concept of recession, we find out the 3 unknowns plus 4th unknown is your time parameter. So that is for correction. So the 3 unknowns is latitude, longitude, and altitude. So all those 3 can be solved by this, the distance between various 3 satellites, right? Okay. And as the distance traveled is with respect to time, in order to remove the clock bias, we need the 4th satellite. So 4 satellites are needed for getting the location of the specific place, right? So anyway, GPS, it is developed by US for the first time by 1970s, early 1970s, and they have to send 24 satellites. So that's why the complete mission has completed in 1994, and it came into existence. And anyway, any GPS system we take, it will have space segment, control segment, and user segment. User segment is totally the users who have the receivers, and control segment is the one which controls all the satellites, and space segment is the satellite and the signal. So the control segment will be controlled by the country which the GPS is owned. So these are the types of receivers which we can use. So many types of receivers, and so many applications it is used, not only in GIS, it is used in military, surveying, mapping, navigation, search and rescue, even in mobile phones, everything. Even our Google Maps use GPS for its applications, right? So anyway, this is done by a collection of navigation systems which provides, and there are a lot of navigation systems now. So as we are discussing here also, we can have the navigation systems at global level, at regional level, and at local level. So local level satellite positioning systems gives very precise location. So maybe it can be used for transport. For example, like in a highway, in an expressway, like 10 kilometers, 20 kilometers, or 100 kilometers, that the lane can be monitored by using this GPSs. And when the lane or the speed changes with the vehicle, then usually this fine is being levied. So all those is under the under this local or local type of GNSS, right? Then we are having some regional level services, like India is having IRNSS, so that's a regional level service, and global level also we can do. So maybe we will discuss in later. And here actually GNSS, it is owned by 6 countries in the world now. United States was the first, then second Europe, then India, China, Russia, and Japan. All those 6 countries, they are having their own GPSs, right? Or you can say that GNSS, right? So, and this satellite navigation is being done by the global constellation, the regional constellation, and the local constellation, right? So the global constellations, it is maybe we can have Navstar GPS, GLONASS, Galileo, and Compass. Navstar GPS is a global constellation which is owned by United States. GLONASS is by Russia, Galileo is by Europe, and Compass is by China. So all those countries they are having. And regional constellation, it is again by China and India. Then local constellation is totally like it is owned by most of the Japan and US, WAS. So these are the satellite augmentation systems, and in the bracket I have given the minimum number of satellites which is needed. So totally all those maintain and all those satellites, and this establishment is totally for getting the latitude and longitude of a specific location. So not only latitude and longitude, it is used for various other purposes also. Like if you want to model the ionosphere, then the data of these navigation systems is being used, right? So anyway, all those combined satellite system, they give 75 number of satellites, which actually increases the position accuracy in urban canyons. So in urban areas, due to the high-rise buildings, sometimes the signal may be maybe stopped because the signal is very weak radio wave radio signal, so it can be disturbed by this high-raised urban areas. So when there is a combination of GPS, GLONASS, Galileo, and BIDO or whatever, then we can get as we have discussed in the slide, there are more than 75 satellites in constellation. So when so many number of satellites are there, then we can have very accurate positioning, and definitely this is having bias as well as errors. So when certain countries, they belong to, I mean, this the systems which will belong to various countries, then the bias also can be reduced. Okay. Then coming to the last part of the first session, AI. So we all are very much using this artificial intelligence because of its efficiency. It is used for climate change also. So what we call it as geospatial AI, it is called. So geospatial artificial intelligence applications can be used for climate change, because as we are discussing, we all know we are speaking so many things like climate change. The data is very big. Maybe we need hourly data as well as we need years together data. Then definitely our system should be very efficient enough to manipulate or to see this data. So normal GIS packages or normal platforms will never. It's very difficult to use the normal package and normal this thing. So we have to go for some artificial intelligence. We have to get the help of artificial intelligence so that it helps us in analyzing, or say it models, it can monitor, predict climate events, and it can analyze satellite images, weather data. They can track the deforestation. So it can handle a lot of data, and it can give it to us. So that's what AI do us. So AI, artificial intelligence and machine language, they can tackle the climate change in more efficient manner. They can do they can take the remote sensing data and they can do automatic monitoring. So that is very important. Automatic monitoring, it can provide fast and it can have time intensive simulations, can be done within seconds, and we can do a lot of decision. Right. So this is how, it can be very well used for understanding the weather pattern. So it's anyway, when AI and ML, it can help to a certain extent for making solutions, right? So the thing is, we can do analysis across the fields. That's very important. Right. For example, we can take this. This is not the complete list, but it shows like electricity, transportation, building, industry, farms, carbon dioxide related, climatic prediction, societal impacts. So many application fields can be considered, and we can use ML enabled methodologies for that, for experimenting, for control systems, for forecasting, and all those. Right. All those can be taken as methodologies to this to these fields by using AI, right? So this is where it stands. Likewise, the machine learning areas like computer vision, like time series analysis, all those can be used, like unsupervised learning. Everything can be used in all those fields, in these actionable areas, in order to get a very good. So what happens is, for example, when we take energy into consideration, a typical wind farm can be like this. But when we do good prediction for wind power production, as well as when we take a better prediction for electricity supply and demand. So when these two and the operational cost savings, when these three parameters are put into a typical wind farm decision, what happens is we can have a wind farm using ML, which will be more efficient than that of which we have predicted by using typical methodologies. So maybe you can say that machine learning helps us by providing an artificial intelligence to us, providing us to get better solutions, right? So for example, when this is the case in a heavy transported area, when the congestion is like that, we can there will be a lot of problems. Like you see, when this happens, there will be a lot of carbon dioxide which is emitted. There is a loss of there is a lot of time which is getting wasted, loss of workforce which is getting wasted. So all those can be taken, like even health issues can become a problem, like physical, mental. Then loss of productivity may happen accordingly, and there will be increase in transportation cost. So when this is the case, then we can have AML derived solutions for predicting this traffic congestion, then so that we can get a very optimized fuel consumption, and we can reduce all those problems, right? So that is very important. Okay, so the climate predictions also can be done, like you say, simulating cloud physics. So the those areas can be done, and we can learn from the satellite data. Then by tracking the storms, and so many parameters can be taken, and we can do a classifying system where AI plays a very important role. So we can predict the effects of climate change, and this prediction can be done very extremely fast and compact. Okay. Okay, so this is maybe in the next session, I will share something related with the AI also, certain case studies which is done by AI, and certain other case studies, normal traditional case studies. So we'll stop here, and maybe we will have some time for some time for discussion. Okay, as already I have fixed this time, please don't take this into consideration, but maybe we will join again at some time. Any questions to discuss? Hello, am I audible?
Yes, madam, you are audible.
Yeah. Any questions for discussion?
If any participant has questions, please raise your hand. Give the thumb. I will unmute you from our from the site. No question, ma'am.
No questions. Okay. Then when shall we join, sir? Or shall I continue?
No, madam. I think a 5-minute break can be taken.
Okay. Okay, sir. Okay. Okay. So whether the slides were visible, sir, in the afterwards?
Now slide is visible, madam.
No problem, no, sir.
No problem.
No. Okay. So I'm worried because there is no questions, no. So I'm worried that whether the participants have understood something, or whether I have justified my time. That's what
No,
was.
madam. In chat box, there are many appreciation of this session. It is really informative session.
Yeah, sir. Okay. Thank you, sir. Thank you, sir. Whether there is any questions in the chat box? There are 22, no? I think there is no questions in the chat box also.
Everyone wants break now. For
Okay.
5 minutes.
Okay, we will have
Okay.
a break, and we will rejoin by 12:55. Okay.
Yes, ma'am.
Okay, 12:55 will join. Okay, thank you, sir. Thank you.
Thank you. Please continue, ma'am.
Shall we start, sir?
Yes, sir. Yes, ma'am.
Okay, okay. Yes. In this session, I will just discuss about some of the applications so that you also can work on your own field, and maybe in future also, maybe you can use the expertise which you have gained in this field, right? Okay, so this is I will show you there's a this is an image which shows the water vapor which is present over the globe, right? So here maybe in the upper troposphere, how much globe is there? And here is the scale where we can estimate the amount of water vapor which is there in the upper atmosphere or upper troposphere, right? And if we can create like for visualization, we can do a three-dimensional coverage, and then we can make people to understand more things. And the satellite sensor may give the estimates of so many parameters, of so many atmospheric parameters, which is very important for the forecasting or the climate change or whatever. Okay, here there's again a picture which is shown, which shows the satellite derived winds, right? Okay. Is my slides visible to you?
Yes, ma'am. Slide is visible.
Okay, okay. So here, maybe we can see like so many the wind direction which is shown in various arrows, and we can predict the cyclones wherever it goes. So this is where again it is used in meteorology. So mostly we can see such type of images in our daily weather forecasting, where satellite images are being used. So this is a very important area where artificial intelligence also can help a lot. Because each and every time we need to analyze, we have to do, and everything is very fast nowadays. Even in developed countries, usually when there is a storm or when there is a typhoon or whatever, even a cyclone or whatever, where after the event, within maybe within a 24 hours, they have to disperse all the insurance amount or whatever. So when this happens, when this is the request, then within 24 hours, we have to work on the losses, what loss has happened to which person, So for this type of analysis, maybe each and every person will have their own value of properties, and the value of the property should be there in the JS database. So immediately after the storm or whatever hazards has happened, immediately you can get the database which tells you about the loss, as well as it helps the insurance company or whatever to disperse their insurance, or it helps the government to have a very better decision in a very fast manner. So satellite data plays a very important role, or our JS techniques or whatever geospatial perception plays a very important role in giving the information immediately. And we should then the computer technology as well as the AI and whatever, it's a very big thankful to them, because they are the persons who help in such a manner in solving those spatial information. So likewise, we can have wind vector or vectors also, where the surface winds also can be monitored. So this works in very, maybe we can monitor the summer, winter or whatever. So likewise, we can have like some rainfall estimates, where we can say that these are the areas where there will be very heavy rain, and it can be forecasted also. So the rain rate can be observed and it can be forecasted, and the information can be given to the countries who are in need of that, and we can even guide the people to act accordingly. So there are forecast rules also, and we can even model that, and based upon the rainfall conditions, the rainfed areas can be given some decision telling that this year the rainfall will be in such scenario, or in such totals. So accordingly, you have to cultivate such type of crops. Maybe if the rainfall is very less, you have to go for dry crops, and if the rainfall is adequate, then you go for wet crops like paddy or wheat or sugarcane. Whereas when there is when the conditions are in drought, maybe we can forecast and we can we can educate the farmers to go for dry agriculture like millets. So this is the way by which agricultural or crop protection can be properly managed by using this tool. Moreover, when there is a heavy rain, then we can predict and we can tell the inhabitants to get a better place, or we can do some evacuation methods also. So all those can be done by the technology. So this is again this is the normal picture which we undergo when we see news and all. And the Gaja cyclone or whatever cyclones, they can be very well monitored, and we can even model, and we can say this is the way by which this the rate of the speed is like this, and at this specific point of time it will hit the shore. So these type of forecasts or everything is done by using the meteorological satellites. So meteorological satellites, they play a very important role in designing or in guiding us to take proper decisions. So likewise, we can see the global carbon which is seen by the satellite sensor, and that's we can at the global level we can say which are the areas which is having this much of carbon. So here dark blue area shows that this is like 387 ppm parts per million carbon is there, and red areas are the areas which is having 402.5. So it shows the atmospheric carbon which is there above in the atmosphere throughout the globe, and those countries can be warned, or we can do some measures thereby the carbon is being reduced. And likewise, maybe it can be connected, like when we use GIS, we can connect such type of carbon with the health issues or the impacts in the health of the people, and even such type of so many analysis can be done. And each and every day we can get this information, and we can see how it changes, and we can make an animation of this, and we can even the carbon level changes like this, and based upon a set of data, maybe within maybe years together, maybe 10 to 15 years data, we can take and we can do a modeling, and then we can predict for again for 10 years or 15 years or whatever. So prediction also can be done. Even this is the scenario in this growing population, and the demand will be more. Accordingly, the carbon might be changed. So accordingly, so many analysis and modeling can be done by using satellite data. And the interesting part of this is the estimation also. Parts per million type of estimations also can be done by using satellite sensors, even which any survey methods cannot give. Right. So the proper and maybe this can be made as a record, and it can have at this particular point of time the carbon was like this, and at this particular point of time the carbon has reduced. So what is the reason? So such type of analysis can be very well done. Right. Here is another this thing, like I can tell you about the carbon dioxide this thing. And maybe it can be put in a time graph, and we can say like, this is the rate by which the carbon concentration it increases in the atmosphere. And we can just predict this line, and we can form a linear equation, so that we can say maybe at 2019 the scenario is like this, and at 2030 what will be the scenario, and according to that scenario the proper plans can be taken. Okay. So this is again a satellite image which shows the aerosol optical depth, the same principle, where it will tell the aerosol distributions. Similarly, we can do it for the particulate matter or whatever. Let anything be the pollutants, but the satellite images can give an idea for this. So anyway, we know that when there is a lot of sulfur dioxide or so many other pollutants in the air, that may decrease the temperature of the earth. So how much it decreases, so that what will happen to the productivity of the crops. So such type of advanced analysis also can be done when we are using such data. And as this data is unbiased, nothing can be changed here. So we can have a real-time, real-time information can be got. Here, all the red areas, they indicate the places where there are high concentration of this aerosols. And when we put this map in our GIS, then we can change the scale also accordingly, right? Maybe I need not want this color. Maybe the color of this imagery, maybe I can change. Accordingly, we can do. Maybe if I want to put here, maybe if I'm having a running scale, then if I want to classify this according to my wish, maybe I have to see which are the areas which are having greater than 0.5 aerosol depth. So just I can classify that, and I can get a map telling that. So immediately it will give 0.5 and above areas are these areas. So we can talk to the government so that they take proper measures to control. So likewise, this is an imagery which shows the particle of dust particles which is there in the and the imagery shows the dust particles which is being there in the atmosphere, and the transection or traverse is drawn across, and accordingly you see we have created a graph which shows when the altitude is like this, the dust storms will be like this. So likewise, weather radar also gives so many information. For example, weather radar products, they can be used for forecasting as well as warning, mostly for tropical cyclones, then rainstorms and quantitative rainfall forecast, right? Okay. So for tropical cyclones, mostly we know the tropical areas or the areas where it's very fragile. every now and then we'll get cyclone, or every now and then the tropical areas will be affected by rainstorms or whatever. So these are the areas where more concentration should be given. So maybe so that's why specific specific satellite is being sent to this tropical a satellite called as Megatrophics is sent to this tropical area alone, and it will monitor only the tropical area, and it will give the rainfall measurements of this area. We know the tropical area is very important from agricultural point of view, and such type of cyclones can be monitored and it can be given, right? Okay. So this is the methodology by which even though the data is older, it can be used for real time also. So for today's data or whatever. So the idea behind is like it can be used very well, like for rainstorms also, and we can say that how many areas or how much rain may happen at the specific place. So this is a place where in the Pearl River estuary, where the rain band shows areas of blue, green, and other things. Where the area which is showing yellow or orange, these areas are the places where heavy rains is going to happen, and the lighter rains are in light blue and green. Right, red and yellow shows very heavy rain, and the how much rain is also being estimated or can be estimated, or it can be forecast by using this. So this is how quantitative rainfall forecast also can be done by using the satellite data, right? And we can have like 1 hour total rainfall also can be got, and it can be monitored like this. So this can be done for all the countries like this. So the tropical rainfall measuring mission, TRMM, so that gives the data, radar data, which gives the rain bands and which says this much millimeter per hour of rain may come. So it's to the scale, and we can even overlay this with other themes, and then we can analyze that these are the rainfall areas, right? And we can even see the circulation pattern of a typhoon, and it can be analyzed. So all those are examples for the meteorological part. So as far as meteorology is concerned, it's a very dynamic in nature. All the meteorological parameters are so dynamic, and then they change with the day, hour of the day, they change with the season, they change with the year, and so many changes are there. And the data requirement is also more, and remote sensing is able to give the data, and GIS is capable of analyzing all those, and it can be, and now artificial intelligence also has come in order to do all the process automatically. So automated analysis can be done very efficiently, and decisions can be made very efficiently. So the meteorological part in this dynamic environment also, the dynamic environment also, geospatial perspective plays a very important role in analyzing. Similarly, for sustainable development also, if we need to find out the area where in globe the degraded lands, right? So this shows like those are the degraded lands, and non-degraded lands. Maybe red is the most land which is degraded. So we can have some indices, and based upon the index, we can calculate the degraded lands, and we can give proper measures for them, telling that okay, these are the. So global level monitoring also can be done. The same analysis can be done for local level also, and we can find out okay, these are the villages. Maybe for a district level administration, these are the villages where the degraded lands are more, or these are the villages which are facing the problem of degradation. So accordingly, certain measures like soil erosion, or any other parameter, or maybe fertility of the soil, these and all can be maintained. So from sustainable development point of view, sustainable land development point of view, we can find out the satellite data gives a very proper analysis, and we can overlay. So actually, when satellite data comes, the administration unit and all never will not be there. Whenever it is georeferenced, and whenever it is got into there, we can place the administration units there, and we can analyze at a local level also, telling that this is the information, or this has to be given But so similarly, this can be done for desertification also. So we can find out the desertification vulnerability, telling that these are the areas where the vulnerability of desertification is less, moderate, high. And you can see that India comes under mostly very high, and moderate area, right? So desertification is a problem as far as India is concerned. So likewise for other countries also, the analysis can be done. So we have to take proper measures in order to reduce this desertification. So like we can take the climatic parameters. So climatic parameters is natural, and if this is being accelerated by anthropogenic activities, then steps has to be taken for reducing this anthropogenic activities, right? Desertification vulnerability. Is the slide visible to you?
Yes, ma'am.
Okay.
Slide is visible.
Okay, thank you. Okay, so this is being, as we have discussed in remote sensing part, here mostly NOVA AVHRR data will be used where the global level data can be got. So NOVA AVHRR has a very high temporal resolution. So that means in one day we will get 2 data. So 2 data, every 12 hours you will get a data. So that will tell you the whole globe every 12 hours. So you can have a very high temporal resolution, but the spatial resolution is less because we have to analyze the whole globe. Right. So accordingly, we can use that for various purposes. Maybe as I have shown in these 2 slides, like degradation and desertification, this can be done like as it is global level. Then we are taking the data product of NOAA AVHRR, where the spatial resolution is like 4 kilometer. 4 kilometer at the NADR it is 1 kilometer. So 1 kilometer data we are using. Whereas if I want to do for my state, then I have to go to IRS list 3 in Indian remote sensing satellite list 3 data, which is having 23 meters resolution. So the resolution which we take is dependent upon the scale in which I am doing the analysis. If I want to do like a village level data, then I can go for Iconos data or Cartosat data, which is 1 meter resolution, right? So it depends. So anyway, all analysis has to be done at various scales according to the applicability, and accordingly I have to choose the data product and we have to use the analysis. So the methods are the same, the application as well as the data by which we take it is n number, and accordingly we have to use the data. And this is another example showing the deforestation principle. Like this also can be used for sustainable development. Like in 2002, the forest scenario was like this, and in 2011, the forest is being little bit reduced, and at 2016, the forest has been reduced a lot. So here we are using the true color composite, where the forest is seen in green color, right? So maybe we can have a temporal analysis like this, right? Every now and then, maybe I can do analysis telling that every 5 years I will take, or every 10 years I will take. Accordingly, I can do the analysis and I can say that, oh, this is the rate of reduction in forest, and what will be the scenario of forest after this many years. So here, not only the reduction in the aerial coverage of the forest, we may take cite another layers also. For example, yet another criterion also, like the temperature conditions, maybe the rainfall conditions, then the anthropogenic activities for timber or for whatever. So n number of information can be given here. Even natural calamities like landslide, forest fire, or even that also can be taken as a criterion in determining this loss. So I can say, okay, the forest has deteriorated in such a manner, and we can search for the reasons why the forest has deteriorated. So we can find out the reasons and we can work on it. That is at one hand. And maybe on other hand, I can say that, okay, these are the areas where I have to give priority and increase the forest cover. So in such a way, the decision making can happen. Like for a sustainable development, we can take into account like deforestation, desertification, and degradation land, so that considering all those, then we can prepare a proper management plan by which our Mother Earth is being saved, right? Okay, now we will, so these are the traditional applications. And as we are thinking with this, when climatic or when weather parameters come into consideration, then you see the data will be very large enough. Sometimes we know our software will have a capability of handling the data to certain limit, right? So when the data goes beyond the limit, the software and our hardware may not be able to handle. So that's why what we do is when hardware is not able to handle, maybe for example, my computer memory will be maybe some TBs, maybe 1 TB or 2 TB. But when the data goes beyond my computer limit, then what is the solution? So then we go for cloud data, and we store our data in the cloud, and we will be working on our system. So that is a very advantageous part from computer scientists. So they have helped, the computer scientists have helped a lot in geospatial data management by providing here, for example, for geospatial data, we use Google Earth Engine, GE, Google Earth Engine. So that is a model which is used in web, and it uses the cloud for storing the data, and all the data which is available will be there in the Google Earth Engine. It's a platform, and in that platform you can do your own analysis, you can create your own your own applications, and then we can download the data and you can take. Maybe for example, I am doing maybe I'm having the example for that. Maybe if we are doing a decadal analysis of any weather parameters, then it can be done in Google Earth Engine, and I can train the model, or I can train the system to do some analysis, and I can get the information, and we can use it for decision making. So we can do like the platform can be used, and it can be, the data can be fused from so many domains, maybe remote sensing, maybe GIS, or some other portals, and they can be fused, and we can get a new data, and that new data can be, and the system or the GE can be trained in such a manner to do automated interpretation, and so that we can get the decision very fast, right? Likewise, Python also can be used. That's also a part of artificial intelligence, because Python, it's a language, and it's very simple, and we are having so many libraries and frameworks for Python, and it can be very much used for geospatial analysis, or we can do many multidimensional data sets, and it can be analyzed, right? So many AI models which uses satellite imagery, sensor data, historical weather pattern, then so many other information from so many other sources. They can be used, like for example, even it can use the data like from buoys, which is there, which is installed in the ocean. So such type of data and all can be taken, and it can be combined together, and certain models and estimations can be done. The only thing is, whatever data we have to get, it should be in it should be georeferenced. That means it should give it should remember the latitude and longitude. Right. So whatever data we get, when latitude and longitude is there, so many analysis can be done. So Python is another machine learning program which is being used. Likewise, R is also another. R package is also another by which it can be used for so many statistical analysis, as well as to do some analysis based on the big data, right? So these three, and mostly out of all those, Python is very easy, and Google Earth Engine is, maybe you can say that, already tailored one, and Python and R even it can be customized by the user. So like traditional GIS analysis is there, whatever we have discussed, and even we can do some customized the analysis. Like if I am very particular about certain applications, according to my particular requirement, I can customize the software, or I can automate that according to my wish. And maybe the only thing is I have to program the system according to my wish. So that is where the advanced analysis of GIS stands. So not only the traditional analysis which can process the spatial and temporal data, even we can use it for a new analysis based upon the application parameter, right? So for example, usually we speak about space, the locational parameters. Sometimes we may speak something about the social phenomenon or some religious phenomenon or even some emotional thoughts. Even that can be converted into maps, and even that type of analysis also can be done. So all those, when Python and R is with us, we can customize our own system, and so that it can predict more things. So now the applications of the geospatial science is being very broader and broader, which includes many things. Okay, so now maybe I will present a small case study which is being done by us very recently. Maybe you can go, we can discuss about all those, and we can have you can frame your own study, and you can do it by using this thing. Okay, anyway, here when we think about earlier actually the data and softwares were costly, and it was limited to certain people. But now all the softwares, they are kept in cloud, or they are free of cost. We are having open source softwares for all analysis, either it be satellite data processing or it be vector data processing, whatever, or even if you want to do geostatistics, everything is available open source. Maybe we can say that Python or the GE, everything is open source, and we can use that. And even the data also, whatever meteorological data, whatever. So according to the geospatial space policy, which has been framed, actually all those are developed by the tax amount of the people. So what happens is nowadays everything is being kept open source. So we can the analysis part, even there is no restriction of the amount which is being spent. So we can use the open source, and you can do a number of analysis, and we can do something for the climate change. So this is a small study which we have done very recently related to the air quality of South Tamil Nadu. So South Tamil Nadu, it nearly takes nearly 48,000 square kilometers, which includes 11 districts. So all those has been taken in a very broad manner, and it's very difficult. You think just nearly 50,000 square kilometers of area is being covered by survey and all. It's very difficult. And the data is also, what happens is the data is also so large enough which cannot be processed by the normal GIS platform. So we just took the Geo AI tools into our study, and we used all the Google Earth Engine as well as R and Python, and we have done a study here. And mostly we have just made like we have taken nitrogen dioxide, PM25, PM2.5, and AOD as the parameters as the pollution parameters from the atmosphere. And then we have taken the meteorological parameters also, and then we have related all those by using spatial autocorrelation, right? And some results have been got. Okay, so this is how mostly we have taken like MODIS data, MODIS, then Sentinel-5P images. All those is being taken from GE or Google Earth Engine, which contains the data. Here what we have done is we have taken monthly data, right? Monthly data for 2 decades. And in Google Earth Engine itself, if you think just for 20 years, if you are taking monthly data, what will be the storage? So that's why it becomes very difficult for us to use in a system. So that's why what we did is we have got the help of GE, where the storage will be in the cloud, right? So, but whatever analysis you can do, user-specific analysis can be done, and the maps can be imported, and it can be processed, right? So in Google Earth Engine, the only thing is we have to write the coding, and codings also mostly R coding, Python coding, and GE coding are already available in the libraries, and we have to little bit process or change the file names or change the area. So similar small changes we have to make, and we can make it customized and we can use it for our own studies. So here we have used Modi's derived not only AOD, even we have used all the parameters. I will show you again, and then we have done a statistical analysis also. So this is the image of, like, you can say that it is taken for 3 decades. So 3 decades average minimum temperature is being taken for these southern 11 districts, and we have made like the temperature prediction. So like for minimum temperature, like and we have analyzed like pre-monsoon and post-monsoon, because pre-monsoon and post-monsoon shows certain change. So likewise, all the analysis has been done in the pre-monsoon scenario and in the post-monsoon scenario, right? Average minimum maximum temperature, likewise we have done for precipitation. A small change may be happening. So the thing is, maybe from the study, what we have analyzed is maybe sometimes the total rainfall or the average temperature, there will be no change. But the thing is, the total rainfall may not change, but how it rains, that is very important. There is a change in the season. Sometimes what we will expect rain in the monsoon season, but the rain will be mostly in the summer season, where we will not expect rains. So this is how it happens. Sometimes what happens is, in certain areas there will be, we will never expect rains in certain areas, but at certain time that areas will be heavily rained with very intense floods, right? So these are the results when we got, when we properly analyzed the monthly rainfall parameters and the annual rainfall parameters. We came to know such type of changes in the intensity as well as in the frequency, right? Not only the intensity of rainfall, even in all other parameters. Sometimes the if the total rainfall or the average temperature is being maintained, there is a shift there. So this shift actually creates a lot of loss in our agricultural system, right? Okay. So likewise, the tropospheric nitrogen is being monitored, and this is very important. We have converted it into micromole per meter square, and this is an unbiased data, right? Unbiased data, which we can take the estimates, and all those has been taken, like the aerosol optical depth, then particulate matter, everything in pre-monsoon and post-monsoon, and we have done a spatial autocorrelation by using R, and the correlation coefficients are there, and we can explain with reference to this correlation coefficients, right? Negative and positive correlation, telling that these green areas are the places where when precipitation increases, this thing also increases. Such a type of correlation analysis also can be done by using our package, right? Okay. So this is how we have done a small study, and this is the response given to the climatic change as a researcher, right? So we know that I'm going to end the session by telling that we have borrowed our earth from our ancestors, and we have to give to our descendants. We have to repay it to our descendants. So earth is a place where it is given as a rent for us. So we have to pay the rent, and we have to be in the earth, and we have to give the earth without damage to our descendants. So that's very important. And with this aim in our mind, we have maybe we are organizing a refresher course in like climate change and sustainable development. So that's what we speak more about, sustainable development. And our sustainable development goals also has 6 goals related to this climate change. So definitely. So if we want to give the earth as such to our descendants, then definitely there should be a radical change. Professor Mary Ryan, she actually says that, see, there should be a radical change, right? Addressing the challenge of global pollution or whatever is a radical shift in our industrial systems, technologies, business models. Everything has to change totally so that we see a total very good earth is being given to our descendants. So there is a lot of research ideas which has to be addressed. Maybe I have given a very small list which was in my thought process, and there are a lot of places where you can do. So we can do research in plankton, which can form as a carbon sinks, like waste the microbes. So many places are there for research where we can address the climatic challenges, right? Climate change challenges, right? Okay, thank you. Thanks for this references, which is got from so many sources, and thanks for the patient listening. And if there is some doubts or some other clarifications, we can speak for 5 to 10 minutes.
Yes, ma'am.
So is there any?
Those who want to ask questions, please raise your hand. I will unmute from my side.
पार्टिसिपेंट को कुछ क्वेश्चन होंगे तो आप रेज द हैंड कर सकते हैं। आपको आपका माइक अनम्यूट करके आप बात कर सकते हैं मैम से। हेलो, प्लीज आप आपका माइक अनम्यूट कर सकते हैं पार्टिसिपेंट। हाँ मैम, वो ना चैट बॉक्स में भी आपको डाल रहे हैं मैसेज वगैरह।
If somebody needs clarification, you can give in the chat message also. I am seeing the chat message. Only thank you and appreciation is there. If there is any question, you can post in the chat session and I will address.
रोल नंबर 52। हेलो
Sir,
yes,
Sir,
yes.
no question. Sir, no question, but the session was very informative and interesting. Thank you so much, ma'am.
thank
Yes,
you. But sir, I see that number 52 or somebody is asking for unmute or something.
yes मैम, ऑलरेडी मैंने उनका अनम्यूट किया है 52 का। yes, participant, any question? yes, okay, thank you. Roll number 19. Roll number 19. Roll number 19.
I think 17 has want to ask question.
Okay, sir. Okay.
Okay.
Sir, good afternoon, sir. My vote of thanks is evening, sir.
Yes. Okay. Roll number 19, please vote of thanks.
हो गया
19.
Yes, sir. Good
Sir,
afternoon.
roll number 17 has raised the hand.
Yes, I raised my hand because I was muted, sir.
No, you can unmute from your side now.
Now I am able to. Shall I start the vote of thanks?
Somebody has asked one
Yes,
question. Please, sir. There's a question like why it is difficult to predict climate in India? Yeah, really sometimes we have this problem. As far as maybe I may be wrong, but sometimes as far as my vision, we are a developing country. So what happens is we are not that much precise in our database. So that is the first thing. When you see developed nations, they spend a lot for having a proper database. Now only we are entering and we are trying to keep our database very proper. So that is one thing. And the second thing is we are sending a lot of, even you see space science is very good in, India is very good in space science. But when it comes to product and when we are using, the manpower is less. We see that in our field. So in geoinformatics, even I told you right, but from the beginning, we have maybe 27 batch of students, they went out, but all of them got job. And still, you say, I get calls from companies telling that I need some more person. So you say there is a lot of manpower requirement to work in this field. That too, whoever learns very thoroughly the remote sensing, because this geospatial perspective, it depends upon how the people learn, how they understand, and how they use. So that's why we lag in that also. So from my point, I can say that the first thing is database is not that much precise. And maybe in future days, maybe definitely we will spend a lot, or we are trying to keep our database good. That is the first point. And the second point is we need more manpower in all fields. So maybe here, maybe as far as we may talk remote sensing only, maybe earth science people and environmental science people may alone speak about remote sensing. But it's not like that. Even an engineer, even a physics person, even a chemist, everybody has to talk about the geospatial data. So maybe in future years, definitely we will get a very good, precise information so that we can predict climate very precisely.
Madam, one more question.
Yeah.
Our nation is very different climates, and there are very much states they have very different climates. So any national policy for the all state that they have to control the climate change?
Yeah, actually, National Disaster Management Authority is there, NDMA, right? And they are having like state level and district level officers to monitor the climatic changes and other things. So as we know, India is a very varied country where in one place you will have flood, and simultaneously in other place will be having drought. Definitely it is needed, and accordingly it is there. That's why we are managing still, right? And Disaster Management Authority, as well as we would have heard about IMD. IMD is having regional meteorological divisions to take care of the climate of regional area also. So accordingly, we are having, and satellite gives data for all the place. Even not a single part of globe is not covered. So even sitting in the lab, and when they analyze, we can give a very good decision for a varied climatic zone like India, right? Did I satisfy your question? And there is a question like, how can remote sensing techniques be leveraged to monitor and manage land use changes, soil erosion, and vegetation dynamics in hilly regions, and what are the key challenges? Okay, so this is a good question. Like, usually remote sensing is used to manage land use changes and monitor, because we know that we are having data at various resolution from 1970 onwards. From 1973 onwards, we are having data at 30 meters, like 72 meters, then it came to 30 meters. So from 30 meters data, you are having like 30 meters resolution data. From 1980 onwards, we are having with us. So when we georeference and when we are having a very good software, and that software will automatically say this much land use has changed. So it can be very well used for managing land use changes, right? We can have a proper record. The only thing is we have to take season into our consideration, the spatial resolution into our consideration. So spatial resolution and season, maybe post-monsoon or pre-monsoon, when these two issues are taken into consideration, and when we select proper data, land use changes can be very well used. And there are so many models also telling this much change can happen. And as far as soil erosion is considered, we are having modified USLE equation where you can map the soil erosion properties, and it is taking all the erosion parameters into consideration. I think there are 7-8 parameters which is taken into consideration for modified USLE. And that is a linear equation where in GIS you can do, and you can mark the particular soil erosion sites, and we can give proper measures for that in order to reduce erosion. We can give proper measures. If it is in a hilly terrain, you can go for contour bunting, or you can go for terrace cultivation, and whatever. So likewise, we can manage soil erosion also. The third point is vegetation dynamics. So as I told, like if it is a very large area, you can take NOVA AV HRR data, and we can see how the vegetation changes with reference to ecosystem. So ecosystem monitoring or the changes in vegetation can be done very easily. Now itself we are doing. For example, NOVA AVHR data is taken, and immediately automatically NDVI is done. Normalized difference vegetation index is being done, and the change in dynamics is being very clearly given. And as far as hilly regions is considered, the very important challenges, like all remote sensing analysis ends with ground truth verification. So when it is a hilly terrain, ground truth verification plays a little bit role, but hill area analysis is also very well done by using remote sensing data, because when we study about remote sensing, advantages of remote sensing, one of the important points is it can give data of inaccessible areas. So wherever we can't go, the satellite can take a picture and it can give to us, so that we can do a very good analysis for hilly areas also. Sometimes we face problem in when we are in a hilly terrain, the remote sensing data also will have shadow in its in the data, and even there are certain advanced image processing methods where we can manage that, but still that becomes a little bit challenge because the tone and other parameters may change. So, but still that also we can. It's being modeled, and we can very easily remove that problem also. So as far as satellite or remote sensing is considered, hilly terrain also doesn't have that much of challenge. A little bit of difficulty will be there in analysis. So we can say that remote sensing is a very good tool for analyzing the inaccessible areas like hilly regions. Have I clarified your doubts, sir? Or any other I have to discuss?
Rule 43 is asking question.
Yeah. Welcome, sir. You can ask. Is there in the chat? Which softwares you are using for GSA? What's that GSA, sir? I want that that full form of geospatial analysis. Yeah. Yeah. So actually for geospatial analysis, we use QGIS mostly. Mostly we use QGIS, but we give students like RGIS, YEDDA for YEDDAs also we take for our students. We used to teach them YEDDAs and RGIS, and we give training on QGIS also. QGIS is an open source, whereas YEDDAs and RGIS, they are paid versions, right? And here, as in the case studies, mostly we have used R and Python and GE alone. Any other things, sir?
Ma'am, actually, you delivered a wonderful session today, and we learned a lot of new things. Thank you very much.
Thank you, sir. Thank you for your appreciation. But still, this is my area, and you are all of you maybe new for this area, and mostly few of them would have known most things about this. But still, I thought of sharing a little bit, which I am clear. Okay, I hope that I have satisfied you a little bit. Thank you. Is there any questions you can ask? Maybe we are having some more time, or else we'll stop. Any other questions? Have I skipped in chat?
Participant, any question? Well, no question. Roll number 19.
There is no question, sir, now.
Okay, roll number 19. Roll number 19. रोल नंबर 19, आपका माइक अनम्यूट कीजिए सर. रोल नंबर 19, प्लीज माइक अनम्यूट करके प्लीज वोट ऑफ थैंक्स कीजिए सर. रोल नंबर 19.
Good afternoon, sir. Am I audible?
Yes.
Sir, actually, my vote of thanks at evening session, sir. Right now, it's roll number 70.
Sir, it's my turn now.
Okay.
I was unmuted just now. Shall I proceed, sir?
Yes, yes.
Good afternoon, all. On the behalf of all teacher participants of this refresher course, once again, I am here, Dr. Mayur Khedkar from Department of Chemistry, Hislop College, Nagpur. I am very much thankful for today's guest speaker, Dr. Suja Rose ma'am. She wonderfully explained all all the concept. That concepts are very much new for us, for enlightening us with the detailed, elucidate information regarding role of geoinformation technology and its application along with case studies. I can say that Madam started a session with the bridging line between sustainable development and climate change. She also focused on the 17 goals, out of which 6 goals are very much depending upon climate change. Madam rightly pointed out our role as a human being in controlling this and our impact on the climate change. I express my deep sense of responsibility and thanks for the madam for enlightening us with your kind words. Lastly, I am thankful to the director sir, assistant director sir, and organizer from UGC Malviya Mission Teachers Training Program, Dr. Babasaheb Ambedkar, Marathwada University, Sambhajinagar. Thank you all of you for providing us a platform. Lastly, I am thankful to all participant teachers for patient listening. Thank you, ma'am. Thank you, sir.
Thank you, sir, for giving a good vote of thanks. And thank you all dear participants for being patient with me, even though my slides was in problem, but still thank. And I also thank Dr. Mule and the UGC HRDC director. Thank you very much. Thank you. Have a nice time.
Thank you, ma'am.
Thank you so much, ma'am.